To me, the wonder of science is in the problem solving. It's love for the method, how you choose to address the problem experimentally.
Paul, as a very innovative scientist, he can certainly tackle any question he wants. And it's a matter of what he feels is the most important questions.
In many ways, I think there are many similarities between being an artist and being a scientist. You essentially start with nothing. You start with an idea. There are almost an infinite number of things that you could do, many, many questions that you could pursue.
You have to choose an important topic to work on. It may take 40 years to solve it, but it is important, it's worth it.
The significance of the problem was critical for him. As an experimentalist, as a scientist, he had this very important quality of being able to focus laser-like onto the problem that he was going to work on, to the exclusion of almost anything else.
As children, we had to learn to entertain ourselves. We didn't have television.
Paul comes from a small town in New Mexico, Raton.
My father was a coach, but he was also a biology teacher. When I was 14 or 15, I was reading a Scientific American, and there was an ad in the back for radioisotopes, radioactive compounds. In those days, you could actually possess certain amounts without a license. And so I talked my dad into ordering them for me, which he did. He got a call at the high school one afternoon from the train station saying, "Mr. Modrich, we have a package here for you that says, radioactive, do not stand within 15 feet of this parcel unless absolutely necessary." But he went down and picked it up and brought it home to me.
He then moved from Raton High School to MIT, where he majored in biology. One can imagine the cultural shock that Paul might have experienced in going from Raton to Boston and the MIT environment.
I was interested in many things at MIT, but I was just amazed at the molecular elegance of what was known at that time about genetic regulatory systems, the manner in which genetic information is maintained and utilized in selected ways. My advisor was Salvador Luria, who was one of the founders of molecular biology, and he got me a job in Ethan Signer's lab, initially washing glassware. That was my responsibility. But they were studying recombination, genetic recombination in a bacterial virus. It became very clear to me that this was the kind of thing. I wanted to be like these guys. I applied to several places for graduate school, but the place I really wanted to go was Stanford because that was the center of the universe for DNA biochemistry. Because of my interest in recombination, I decided that I really wanted to work with Bob Lehman.
Paul wanted to work in my laboratory, specifically on DNA ligase, an enzyme that had been discovered in my laboratory and which turned out to be an important component of the systems involved in DNA replication, recombination, repair, and of course, in genetic engineering. It splices DNA chains together. And his research, his thesis research, which was, I have to say, brilliant, really elucidated detailed chemical mechanism of this very complicated reaction that the enzyme catalyzes.
I really learned to be a scientist working in Bob's lab, not only, from the experimental perspective, but how one chooses to pursue, what questions one chooses to pursue. I had a tremendous amount of freedom, and it was the perfect environment for me.
Paul, during the 5 years in my lab, published 6 manuscripts, important manuscripts. Quite a rarity these days, where 1 or 2 will fulfill the requirements for the PhD.
The first work that we did that was directly relevant to mismatch repair was begun here at Duke, the year I came here in 1976.
The thing that he devoted his life to since the time he began his own laboratory was to understand in detail how proteins can identify and bind to specific sequences in the DNA molecule. Mind you, proteins are rather small, DNA molecules are very long. How do these proteins find those specific sequences?
Paul set out being the good biochemist he is. Systematically, he purified the proteins, and through a series of beautiful papers, he described how they work.
As you probably know, as DNA is replicated, occasionally, but very infrequently, mistakes are made. The enzymatic machinery is not perfect. If those mistakes persist, this results in a mutation which can have very deleterious consequences.
A lot of the hereditary disease, sometimes we call it rare disease, came from the mutation that happened during the replication of those cells.
Paul figured out in E. coli how the mismatch is recognized and how it is removed in exquisite detail, and reconstitute the entire system with purified protein. And that's as beautiful as it gets. He said, I'll take the next step and start working with human mismatch repair. Shortly after that, it was found that humans that have defect in mismatch repair have high incidence of some cancer.
Really an amazing accomplishment.
He really single-handedly did it. Solved the mechanism of mismatch repair, and this is rare in science.
I called Paul the day that I learned that he had won the Nobel Prize. He was sort of overwhelmed. He certainly didn't expect it. He's a very modest guy.
He is and has been very modest. On the other hand, he is also very demanding in terms of the rigor of the science. He wanted his student to be at the forefront of the science instead of follow other people's steps. I remember when I completed my thesis defense, and Paul took me out to dinner, and I was saying, well, Paul, what should I do? And he said, be yourself and do the best you can be. And I still remember that advice he gave it to me.
Paul would not publish something unless he's 100% sure. In my case, 80% I would publish it. It's a matter of personality. I would publish it because I say, as a scientist, we are entitled to be wrong every now and then. As long as we're honest with our presentation, we may make the wrong conclusion, but Paul wanted to make sure he had absolute right conclusion. And so that was another aspect of Paul that I admired.
I considered him even as a graduate student, I considered him to be a colleague. He was at that level. Paul's great success in elucidating the detailed mechanism of mismatch repair, and then the discovery of its application to human health must have been an important factor in the decision that led to his award of the Nobel Prize in 2015.
I certainly say that he is probably one of the greatest students come out of that department, and that is a tremendous accomplishment on his side. But I also recognize that the Stanford department, since the Arthur Kornberg was at the center of those elegant DNA enzymology.
You know, if you look at the Stanford biochemistry department, the faculty in that department have, each of them, a history of a lifelong set of contributions. There were no flashes in the pan. I've been fortunate in that way. I mean, that my lab has been funded since 1974. And in order to do that, you have to keep producing something that is viewed by others as useful knowledge. To me, the really wonderful part has been simply knowing that others value what you have done.